Hey, good morning and welcome back to day 3 of the IC&D 1 course. We're just getting started and I've already got a question coming in from Jerry. Hey Jerry, how are you doing?
Hey Ryan, thank you for taking my question. I was curious, how much do I need to know about the spanning tree protocol for the exam?
Great question. So spanning tree is definitely covered on the CCNA exam. We're going to want to have a practical understanding of what spanning tree does for us within a network environment. Not just knowing the details to pass the exam, but a real firm understanding of what does it actually accomplish. Let's go ahead and take a look. In this environment, spanning tree has been disabled. And what you're going to notice is that we have multiple links between switches 1 and 2. When an unknown unicast is sent from switch 1 to switch 2, it returns back to switch 1 because of that extra link there. And because spanning tree's been shut off, what we're going to have happen is those frames are going to go around and around and around. And every time the frame comes into the switch, it has to relearn that MAC address on that particular port. Now alternatively, if spanning tree is enabled, what that's going to do is place one of the redundant links into the blocking state. And by placing that into the blocking state, we'll achieve what's referred to as a loop-free topology. Because the topology is loop-free, it's going to help us stabilize those MAC address tables so that we no longer are learning different source MAC addresses on each port going back and forth. This will provide a stable environment. Alright, I've got a question that came in from Mario. It says, I'm new to the role of network admin. My predecessor is gone. How can I make sure spanning tree is enabled? Great question, Mario. Let's go ahead and pop over to a CLI of a Cisco switch and take a look at how we'd actually get that done. Alright Mario, so what I'm going to do here is I popped into a 3750 switch and I'm just going to issue the show spanning tree command. Now regardless of which platform you're on, 3750, 6500s, 2950s, etc., the show spanning tree command is going to be the same. Now we can do this on a VLAN by VLAN basis. If you question mark, notice that we can look for a particular VLAN. Because we run per VLAN spanning tree, when I issue the show spanning tree statement, we're going to see each VLAN. So here I see VLAN 1, VLAN 2, in VLAN 127. Now VLAN 127 is going to be my primary VLAN. This is what, me personally at my home, this is where all of my devices are connected. So what you see just behind me are the ports of the switch that are connected to other devices. We see that gig 10/1, 10/3, 10/5, etc. These are all access ports that are going out to the users. We see that their port role is a designated port, and you see that they're in the forwarding state. If I continue to go down through the syntax here, we can find our root port, and this is pointing towards the center of our spanning tree, which is what we call the root bridge. Just curious if we've got any other questions. If there's any other questions, go ahead and fire those off. If not, I've got a question coming up for you. How can we ensure that load sharing is accomplished in a Cisco PVST or per VLAN spanning tree environment? A, we manually configure separate root bridges. B, load sharing occurs automatically. C, load sharing is not possible. Or D, we have to use MSTP. All right, I've got some good answers coming in here. I've got more good answers, mostly good answers. All right, just about everybody's getting this one. This was a more advanced subject that we talked about yesterday. The answer to this one is actually we have to manually configure per VLAN spanning tree to use different root bridges to achieve load sharing over the redundant connections. I'm going to bring in a guest expert, Desiree, to talk about why this is actually required.
Even though spanning tree is enabled by default, you'll want to be sure to designate separate root bridges in the core. This is going to ensure load sharing between our access layer and our distribution layer. Let's say, for example, we were looking at VLANs 10 and VLANs 20. VLAN 10 is going to be forwarding out path A and blocking over path B, whereas VLAN 20 is going to be blocking over path A and forwarding over path B.